Artificial intelligence, or AI, is like a digital brain that's as incredible as it is unique. It's a fantastic mix of math, data, and innovation.
Do you want to learn AI but don't know where to start? Do you feel overwhelmed by the amount of information and resources available online? Do you wish there was a simple and clear guide to help you master AI in 2023? Well, you are at the right place. Stay tuned to master your skills in AI. Let's get started. Number 1. Rule-based AI learning. Rule-based AI learning is a type of machine learning that uses a set of predefined rules to store, manipulate, or apply knowledge. These rules are often expressed in human-readable language, such as, if X is true, then Y is true, to make them easier to understand. Rule-based AI learning can be used for various tasks, such as classification, regression, clustering, anomaly detection, and decision-making. Learning classifier system helps to learn and evolve rules based on reinforcement learning and genetic algorithms. They can adapt to changing environments and discover optimal solutions. Association rule learning discovers rules that describe the relationships between variables in a dataset. They can be used for data mining, market basket analysis, and recommender systems. Artificial immune systems mimic the biological immune system and use rules to detect and eliminate harmful elements. They can be used for anomaly detection, optimization, and classification. One of the main advantages of rule-based AI learning is that it can provide transparent and interpretable explanations for its decisions or actions. This makes it suitable for sensitive domains, such as medicine, law, or finance. One of the main disadvantages of rule-based AI learning is that it can be inflexible and limited in handling situations that fall outside of the predefined rules. Rule-based AI learning is one of the earliest and most well-established types of AI. It has many applications and benefits for humanity, but it also faces some challenges and limitations. It is important to understand its strengths and weaknesses and how it compares to other AI approaches. Number 2. Interactive AI learning. It can make learning AI more engaging and fun, as the learner can interact with an AI system and see how it responds to their inputs or feedback. This can also increase the learner's motivation and curiosity to explore more AI topics and techniques. It can make learning AI more personalized and adaptive, as the learner can receive customized information or guidance from an AI system based on their level, interest, and goal. This can also improve the learner's retention and comprehension of AI concepts and skills. It can make learning AI more collaborative and social, as the learner can communicate with other learners or experts through an AI system and exchange ideas or opinions. This can also enhance the learner's critical thinking and problem-solving abilities in AI contexts. Unisim is a generative model that simulates realistic experiences in response to actions carried out by humans or agents. The learner can provide high-level instructions or low-level controls to interact with the simulated environment and objects. The model can be used for content creation, embodied agent training, or video captioning. A neural network playground is an online tool that allows users to tinker with a neural network in their browser. The learner can change various parameters and features of the network and see how it affects its performance and behavior. The tool can be used for education, experimentation, or fun. Number 3. Limited memory AI learning. Limited memory AI learning is a type of machine learning that uses previous data or predictions to improve its performance or behavior. It is different from reactive AI, which only operates in the present moment and does not learn from past experiences. It can help us understand how human intelligence works, as humans also use memory to learn from their past experiences and make informed decisions. It can help develop more advanced and realistic AI systems, such as virtual assistants, chatbots, and autonomous vehicles that can adapt to changing situations and user preferences. It can help explore the potential and limitations of AI, such as how much memory is needed, how to store and retrieve memory efficiently, and how to balance between memory and computation. Virtual voice assistants are systems that use natural language processing and generation to interact with humans. They use memory to store user preferences, past interactions, and contextual information, and use them to provide personalized responses and recommendations. Number 4. Data accumulation. Data accumulation is the process of collecting, storing, and organizing large amounts of data for analysis and use. It can improve the quality and quantity of data available for AI applications. Data is the fuel of AI, and having more and better data can enable AI systems to perform more accurately and efficiently. For example, ChatGPT, a large language model that can generate natural language texts, was trained on a massive data set of over 45 terabytes of text from the web. It can enable the discovery of new patterns and insights from data. Data accumulation can reveal hidden relationships, trends, and anomalies in data that can be useful for AI tasks. For example, Midjourney, a tool that uses AI to analyze customer journeys and optimize marketing campaigns, was able to identify new segments and behaviors of customers by aggregating data from multiple sources. It can facilitate the development and testing of new AI algorithms and models. Data accumulation can provide a rich and diverse set of data for AI researchers and practitioners to experiment with different AI approaches and evaluate their performance. For example, Bard, a tool that uses AI to generate music lyrics, was able to test and improve its models by using data from various genres and artists. However, data accumulation also poses some challenges and limitations for learning AI. It can increase the complexity and cost of data management. Data accumulation can create issues such as data quality, security, privacy, governance, and storage that need to be addressed by data professionals. For example, How AI is Improving Data Management is an article that discusses how AI can help solve some of these problems. Number 5. Theory of Mind AI Learning. Theory of Mind AI Learning is a type of machine learning that aims to endow artificial intelligence systems with the ability to understand and interact with the thoughts and emotions of humans and other intelligent entities. It is the third level of AI, according to the classification proposed by Arend Hinsey, and is still in the innovation stage. Theory of Mind AI Learning is based on the concept of theory of mind, 2M, which is a psychological term that refers to the cognitive capacity to attribute mental states to oneself and others. TOM is a key component of human social cognition, as it enables us to empathize, communicate, cooperate, and predict the behavior of others. Some of the applications and benefits of theory of mind AI learning are: it can improve human-machine interaction by making AI systems more natural, intuitive, and personalized. For example, virtual voice assistants, chatbots, and social robots can use theory of mind AI learning to provide better responses and recommendations based on the user's mood, preferences, and context. It can enhance machine-machine collaboration by enabling AI systems to coordinate and cooperate with each other more effectively. For example, autonomous vehicles can use theory of mind AI learning to anticipate and avoid collisions with other vehicles or pedestrians. It can foster ethical and responsible AI by making AI systems more aware of the impact of their actions on others. For example, medical or military AI systems can use theory of mind AI learning to consider the moral values and consequences of their decisions. Some of the challenges and limitations of the theory of mind AI learning are: it is difficult to design and evaluate theory of mind AI learning systems, as there is no clear or universal definition or measure of 2M. Different agents may have different levels or types of TOM, depending on their cognitive abilities, cultural backgrounds, or personal experiences. It is hard to ensure the quality and consistency of theory of mind AI learning systems, as they may depend on noisy or incomplete data or feedback from other agents. They may also face ethical dilemmas or conflicts when dealing with multiple or contradictory mental states. Which step of learning AI do you find the most interesting or difficult? Let us know in the comments below. Please give it a thumbs up and share it with your friends. And don't forget to subscribe to our channel for more videos on AI and related topics. Thank you for watching, and see you next time.